Hello students, welcome back. The final topic here is section 5, Geometry Essentials. Here's some geometry that you have to know for this course, and the very first is Pythagorean theorem. Whenever you have right triangle, a squared plus b squared is equal to c squared, where c is the hypotenuse. And a sketch of proof, this appears in our textbook by the way. You can arrange this right triangle as pink like this, 4 of them, and then you end up with a big square of side A plus B, and then smaller square with side C. So this smaller square highlighted in blue, the C squared, plus 4 times the area of the original right triangle, 1/2 AB, 1/2 of horizontal times height. That should be equal to the area of the big square, A plus B total quantity squared. That's what we have here. A plus B total quantity squared should be C squared plus 4 times 1/2 AB, and then break up this left-hand side using FOIL method or complete square formula. That's what we have in the second line. A squared plus 2ab plus b squared is equal to c squared plus 2ab. And then 2ab cancel each other out. Voila, we have the Pythagorean identity. There are other proofs, of course, but this is the one that appears in our textbook. Here's a similar method using similar formula, using a minus b total quantity squared. This one appears in an exercise set. If you're interested, try. Okay, so much for Pythagorean theorem. Next, some 2D figures. Rectangle. Everybody should know the rectangle. Area is a times b, and the perimeter, you just add them all up, so 2a plus b. Triangle. Again, everybody should know the triangle formula. 1/2 a times h, base times height. 1/2 base times height. The proof is, as a matter of fact, it's like this. An acute triangle. You can inscribe it in larger right triangle, a times h. And please note that this original triangle is the half the area of this rectangle. This part, that part same, this part, that part the same. Similar case for obtuse triangle. You can get right triangle here and subtract away acute triangle. And then you're going to get 1/2 AH. Next, parallelogram. Area should be a times h, where h is height. Now this may not be familiar to everybody, but I think it's necessary at this level to remember this formula. Rectangle, triangle, of course, that's for everybody. That 2 is something everybody should know. Parallelogram. Now, why is that? The proof, as a matter of fact, is pretty simple. Cut off, and then paste it over there, and then what do you get? We get a rectangle of base height AH. So we have base times height AH. Okay, we went to parallelogram. Now trapezoid, I don't know if trapezoid is necessary for this course, but well, here it is. It turns out 1/2 of a plus b times height. The top plus bottom times height. Why is that? Well, one way to see that is to get a copy of the same trapezoid, pink, and then put those two together, and then you get a big parallelogram. And you remember the area formula of the parallelogram, right? The base times height. So a plus b times height. But that's the area of the big parallelogram. and trapezoid is half the size, so that's why we need half of that. Circle. Circle, everybody should know. Pi r squared is the area, and circumference is 2 pi r, where r is the radius. A sketch of proof, kind of like this. If you cut these things up and make pizza pies, like this, 8 pizza pies, and rearrange, and what do you get? We get a sort of parallelogram kind of thing. Now, if you divide further, then you're going to get another parallelogram kind of thing, but with curved top and bottom, and then even further, less curved because you're cutting more. And what we have in the end, this figure will approach rectangle. Eventually, what do you get? Base times height. And height is the radius, and base is half of the circumference. So pi r times r, so pi r squared. Let's see. Do we need to consider 3D figures? Probably not, but here's some. Box. Oh, excuse me. I should have initialized it. I guess. Okay. Okay, now no more error. It was about initialization. Okay, all right. Box A times B times C. Base area is B times C, and then height is A. So base times height. Excuse me, that's for the volume. And as for the surface area, you can cut off and expand those. We call the net. And top area, bottom area, and fourth side. So you can add those up, and then you get 2AB, and then 2AC, and 2BC there. That's how you get the surface area formula. If you actually draw this net, it's easy to see. Next, circular cylinder. Again, okay. We have a circle and then we have height. So base area times height, so pi r squared times h, that's the volume. Now surface area, how about that? Well, here we go. If you wrap around, that's the side, and top and bottom. So pi r squared here, another pi r squared from here. That's why you get 2 pi r squared. And then how about this? Height is h, and the width must fit this circumference, so 2 pi r h. That's how you get the side. That's how you get the surface area formula for a circular cylinder. Circular cone. It turns out 1/3 pi r squared h, and why 1/3? Good question. That will be answered in calculus. So we're not going to consider those at this level. Just remember the formula, and same goes to surface area formula. I don't think we're going to be using surface area formula at all, but there you go anyway. Sphere. So if you have a ball like this, volume formula is 4/3 pi r cubed. Surface area is 4 pi r squared. Why? That's going to be answered in calculus, not here. It's too hard. But remember the formula. Polygonal cylinder, base area times height, that much is certain. And in this case, base area is, let's see, it's a heptagon. And then height, yeah, you can get that. How about the surface area? You're going to get top and bottom plus how many sides there? And each side of the n-gon polygon, in this case heptagon, and the height. You can add those up. Finally, polygonal cone. 1/3 base area times height. Again, why 1/3? That's a difficult question to answer. It's going to be answered in calculus, not here. It's too hard. As for the surface area formula, base area, okay, and then some of the areas of these rectangles. And did I say rectangles? Excuse me. Some of the areas of these triangles. In this case, 5-gon. Pentagon is here, so there are 5 triangles there. Now, how do you get the area of this triangle? Good question. Complicated, so I didn't really bother writing it down. So much for 3D figures, and that's Geometry Essentials. Okay, that's the end of the preliminaries. Everybody have good luck.